Find the following using the two given functions. So we have f of x is equal to negative 2x plus 10 and g of x is equal to 3x plus 7, and they're asking us to determine when f of x is equal to 0, when g of x is less than 0, when f of x is equal to g of x, and when f of x is less than or equal to g of x. All right, so let's start with the first one, which is f of x equal to 0. Well, to do that, we just basically make f of x in the equation equal to 0, and then we solve for x. So 2x plus 10, solve for x by subtracting 10 from both sides. You end up with the equation negative 10 is equal to negative 2x. Then divide both sides by negative 2. And you end up with positive 5 is equal to x. So x is equal to 5 in this equation. All right, so what we found here is that when x is equal to 5, the function f of x is equal to 0. You can check that by plugging 5 in, and you do see that negative 2 times 5 is negative 10, and negative 10 plus 10 is equal to 0. Let's do the second one, g of x being less than 0. So when is g of x less than 0? Well, basically we just need to set up 3x plus 7, which is g of x, and say, hey, when is that less than 0? So we solve a little inequality here. So we subtract 7 from both sides, and we end up with 3x is less than negative 7. Then you can divide both sides by 3 to get the 3 away from the x, and you end up with the idea that x is less than negative 7 over 3. And so whenever your x value is less than negative 7 over 3, you end up with the g of x value being less than 0. Or in other words, the y is less than 0 whenever x is less than negative 7 over 3. All right, for the third one, it says when is f of x equal to g of x? Well, we can show this analytically and graphically. Let's do it analytically first, though. So 2x plus 10 is equal to 3x plus 7, right? So we just set the two equations equal to one another, and we solve. So for example, we could add 2x to both sides here, and then we end up with just 10 is equal to 5x plus 7. Then we could subtract 7 from both sides, leaving you with just 3 is equal to 5x. And then finally, we divide both sides by 5 to get the 5 away from the x. And we end up with the idea that x is equal to 3/5. So these two equations are equal to one another whenever x is 3/5. And then we have one more to show, which is f of x being less than g of x. When is f of x less than g of x? Okay, so remember our f of x function was actually negative 2x plus 10, and our g of x function was 3x plus 7. Now they asked us in the last piece to show that f of x was less than g of x, less than or equal to g of x. So we'll put a less than or equal to between these two. And then we solve just as before. So we're going to, for example, subtract 3x from both sides. I'm going to do that because I want something to happen for us here to just show something as a reminder. So we're going to subtract off the 3x's. We're left with 7 is less than or equal to, and then we have, or 7 is greater than or equal to, let's see, negative 5x plus 10. Okay, now we'd subtract 10 from both sides. And of course, that would give you minus 5x is less than or equal to negative 3, right? That's positive 7 minus 10 is negative 3. And then we would divide both sides by negative 5 to get the x alone. Now here's the thing that I wanted to have happen for us. When you divide by a negative inequality, don't forget that you have to flip the inequality symbol. So we're going to change that to greater than or equal to. And negative 3 divided by negative 5 is just 3/5. So we end up with x is greater than or equal to 3/5. And that is our solution. All right, so whenever x is greater than or equal to 3/5, the values for f of x, or the y values in that function, will be less than the y values in the g of x function. All right, the last thing I wanted to do is just kind of show you the solution graphically for the third one that we did. So remember we had worked out when is f of x equal to g of x, and we found that the answer was 3/5, right? So that's what we worked out and discovered. Let's show that graphically. So I'm going to graph these two equations for us. And we're going to try to do this really carefully. All right, so let's start with the first one, f of x. For f of x, the function was, if you remember, negative 2x plus 10. So that's in the slope-intercept form, correct? The slope here then is -2 and the intercept is +10. So let's plot that on our graph then. So +10 would mean 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It'd be this point here. And if the slope is -2, it means go down 2 and over 1. So down 2 over 1 and we get the point there. And so that's our line. Now, I'm gonna do a couple more points just to make it easier to graph. So again, we'll go from that next point down 2 over 1 and put a point there. And this way it's nice and easy to draw a straight line. All right, so I'm gonna do my best here to connect these properly. Okay, so that's our drawing. Now, from there, we're gonna do the next one. I'm gonna use green for that graph. And the g of x function had a y-intercept of 7 because it was 3x plus 7. So the y-intercept was 7. So 1, 2, 3, 4, 5, 6, 7. It was here. And then the slope was 3. So that means you would rise up 3, 1, 2, 3, and go over 1. And you get a point there. And again, if we went up 3 and over 1, we get a point there. So if I try to connect those really carefully, then we can see that where they intersect is actually right there, right? Right there. And that's the solution. That's where f of x is equal to g of x. That's what we mean when we say you could solve it graphically. And then we found the answer to be, if you remember for that one, 3/5. And so basically you can see that, here's the point 1 on the x-axis, right? Right there is 1. So 3/5 is basically right where our graph is showing, right? So it's somewhere past the midpoint from 0 to 1 there on the x-axis. And so that's where the solution is. All right, so that's very nice. We can also see the solution for the last one we did where it said, when is g of x bigger than f of x? The top part of this g of x, that's higher than f of x, which is basically getting lower here, right? So g of x is higher than f of x right after that 3/5 point. That's why we had the same answer, basically 3/5 for the second piece. So just an interesting way to look at the problem graphically. And it's helpful, but in truth, without careful grid paper, it's probably better to do it analytically the way we did it, because otherwise it's kind of hard to see precisely where the intersection occurs. We know it occurs at 3/5 because we solved it analytically. Looking at it visually, we can say it's somewhere between 0 and 1 on the x-axis, right? Somewhere between 0 and 1 on the x-axis is where that intersection occurs, but where exactly is that? Well, we know it's 3/5 because the analytical approach gave us that answer.